GCE O Level Mathematics, Lecture 25, Quadratic Graphs. Hello everyone, Dennis here. In today's lesson, we are going to learn everything about quadratic graphs. First, we'll learn how to draw the graph of a quadratic function. Then, we learn how to state the properties of the graphs of quadratic functions after we draw the graphs. Followed by, sketch the quadratic graphs in the form of y equals ax squared plus bx plus c, y equals a bracket x minus b squared plus c, and y equals x minus p times x minus q. So once we learn how to draw or sketch the quadratic graphs, then we'll learn how to solve word problems using quadratic graphs. Let's start the lesson by drawing the graphs of quadratic functions. We'll plot the graph of y equals x squared, which is the basic quadratic graph. So before we want to plot this graph, we start with the table, which consists of the x and the y value. So let's start with the x is equal to 3, negative 3, then the y will be 9, negative 2, the y value will be 4, when x is negative 1, the y will be 1, when x is 0, the y will be 0, we continue x1, y is 1, x2, y is 4, and the last number, x is 3, the y will be 9. So once we completed this table, then we can take out the graph paper and start to draw the graph. So we label the x-axis and the y-axis. This will be the origin, and the value is 0. Then we start to draw the positive value of the x, 1, 2, and 3, followed by the negative value for the x-axis, negative 1, negative 2, negative 3. After that, we draw the y value, positive 1, 2, 3, 4, 5, all the way to the largest number that we need, which is 9. Then we can start to plot the point. The first point is negative 3, 9, which is here. Negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. So once we have finished plotting all these points, then we can join these points with a curve. So this will be the quadratic graph of y equals to x squared. So from the graph, write down the characteristics of the graph that you can observe. So the first thing we can see is the graph is a parabola shape, where the graph curves up, which is a smiley face. The graph is also symmetrical, where y-axis is the line of symmetry. We can also see that the graph has a minimum point at the origin 0, 0. So here is the point 0, 0, which is the minimum point of the graph. Now, let's plot another graph, which is y equals to negative x squared, which is also the basic quadratic graph. So again, we prepare the table x and y with the same value of x when x is negative 3, y is negative 9. When x is negative 2, y is negative 4. So continue to calculate the values of the x and the y. And this is the complete table that we get. So once we get this table, we can start to plot the graph again. Repeat the same steps. Start with the x-axis, followed by the y-axis. Then this will be the origin 0. And then we label the positive value for the x-axis 1, 2, and 3, followed by the negative value for the x-axis negative 1, negative 2, and negative 3. So for this case, we follow by label the negative value for the y, because as we can see from the table, all the values of the y are negative number except for the 0. So -1, -2, all the way to the smallest number that we want, which is -9. So the first point is -3, -9, which is this point, followed by -2, -4, -1, -1, 0, 0, 1, -1, 2, -4, and 3, -9. So once we have plotted all these points, we join them together with a curve, and this is what we get. So this is the graph of y equals to -x squared. So again, from the graph, write down the characteristics of the graph that you can observe. So from here, we can see that the graph is a parabola shape. And the graph curves down, or we call it as a set face. It is also symmetrical, where the y-axis is the line of symmetry. And the graph has a maximum point at the origin, 0, 0, which is at this point. Now, let's look at example 1. Draw the graph of y equals 2x squared plus 2 for the range of x from -3 to 3. Based on the graph, state as many observations as you can. So here's the solution. Before we want to plot the graph, we need to prepare the table, which consists of the x and the y value. So since it's stated by the questions from -3 to 3, so this will be the values of x that we can choose from -3 to 3, then calculate the corresponding values for the y, and this is what we get. So once we completed this table, we can start to plot the graph. We take out the graph paper, then we draw the x-axis followed by the y-axis. So this will be the origin, value is 0. Label the positive value of the x followed by the negative value for the y, for the x, and also the scale for the y-axis. So once we have done this, then we can start to plot the point. So these are the points that we get from the table. After that, we join all these points together with a curve. We'll get the quadratic graph of the function y equals 2x squared plus 2. And the observation that we can see from here is that the graph is symmetrical about the y-axis. The graph does not intersect the x-axis compared to the previous example, and the graph intersects the y-axis at 0, 2. The point 0, 2 is also the minimum point of the graph. So this is the point that we are talking about. And the graph is in the shape of a parabola, and it opens outward. Now you can try this example yourself. Draw the graph of y equals -x squared plus 2x minus 2 for the range of x from -3 to 5. Based on the graph, state as many observations as you can. You can pause the video and try to answer this question yourself. Don't forget to prepare a piece of graph paper. So here's the solution. Before you want to plot the graph, you need to prepare the table, which consists of the x and the y values. So as stated by the question, the range of x is from -3 to 5. So I prepared the table. The first value is -3 and the last number is 5. Okay, then we calculate the corresponding value for the y. So this will be the corresponding values for the y. After that, we can start to plot the graph. Take out the graph paper. We draw the x-axis over here, because as you can see, all the y values are negative. So we draw the x-axis at the top here. Label all the values for the x, -3 all the way to 5 or 4 here. Then we draw the y-axis and label again the scale all the way to 18. Alright, because we have -17 here, so we need to go up to -18. Then we start to plot the point one by one, -3, -17, followed by the second point, the third point, all the way to the last point, 5, -7, -17 here. Then we join this curve together, we'll get the graph of y equals -x squared plus 2x minus 2. Okay, so from here, the observation that we can see is this will be the line of symmetry, and the equation is x equals to 1. So the graph is symmetrical about the line what x equals to 1. So this is the first observation that we can have from this graph. Next, the graph does not intersect with the x-axis. As you can see from here, this graph doesn't touch the x-axis. The graph intersects the y-axis at 0, -2. So this will be the point 0, -2. Okay, the next one, the point 1, -1 is the maximum point of the graph. So this will be the point 1, -1, which is the maximum point. The graph is in the shape of a parabola and opens downward. So this is a parabola open downwards. Next, let's look at example 2. Draw the graph of y equals x squared minus 2x minus 8 for the range of x from -3 to 5. Based on a graph, state as many observations as you can. So here's the solution. Before we want to plot a graph, we need to prepare the table which consists of the x and the y values. As stated from the questions, we need the range from the x is -3 to 5. So I have the x value from -3 all the way to 5. Then I calculate the corresponding values for the y. Once I completed this table, then I take out the graph paper and start to draw the graph. So firstly, I want to draw the x-axis somewhere at the center of the graph paper, because as you can see here, the y consists of the positive values and also the negative value. I need to have some space for the positive value for the y and some space for the negative value of the y. Similarly, I also want to draw the y-axis somewhere in the middle of the graph paper here, because the x we have negative value and also the positive value. So we need to have space for negative x and also positive x. Alright, so this will be the origin 0 here. Then this is the positive values for the x and also negative values for the x. Similarly, this will be the positive value for the y. This will be the negative values for the y. After that, we can start to plot the point. The first point, -3, 7, -3, 7 is here. Continue with the next point, which is here. And the rest of the points, just plot one by one until the last point here, 5, 7. Then we just join these points together with a curve. We'll get the graph of y equals to x squared minus 2x minus 8. So what observation can we see from this graph? First, this dotted line is the line of symmetry. Equation is x equals 1 because it passed through the 1 here, right? Then we can say that the graph is symmetrical about the line x equals 1. Next, the graph intersects the x-axis at 2 points, which is the first point is -2, 0, and the second point is 4, 0. So -2, 0 is here, 4, 0 is this point. We can also see that the graph intersects the y-axis at 0, 8. Alright, so this is the point 0, -8. The point 1, -9 is the minimum point of the graph. So this is the point 1, -9, which is the minimum point of the graph. One more thing we can say is that the graph is in the shape of a parabola and opens outwards. So this is open outwards. Now I want you to try this example yourself. Draw the graph of y equals -x squared minus 4x plus 5 for the range of the x from -6 to 2. Based on the graph, state as many observations as you can. So you can pause the video and try to do it yourself. Alright, so here's the solution. Before you want to plot the graph, you need to prepare the table which consists of the x and y values. The x as stated from the questions for -6 to 2. So for -6 all the way to 2 here, then you calculate the corresponding values for the y. So this will be the corresponding values for the y. Once we completed this table, then we take out the graph paper and start to plot the graph. So first, I will want to draw the x-axis somewhere between the location of this paper, right? Because we see that the y value, we have the negative value and the positive values. We need to have slightly more space for the positive than the negative values, because as you can see, we have more numbers for the positive value of y, and also the largest number is 9 compared to the negative value, which is -7. Similarly, I also want to draw the y-axis somewhere here, because as we can see from the x values here, we have the negative values and the positive value. We need to have more space for the negative values of the x, because as you can see, we have -6. For the positive, x is only 2. Alright, so then this is the origin 0. This will be the positive values for the x-axis. This is the negative values for the x-axis. This will be the positive value for the y-axis, and the negative values for the x-axis. For the y-axis. So once you have all these scales, then we can start to plot the points. The first point, -6, -7. So this is the point. -5, 0. Then continue with the rest of the points, and eventually these are the points that we can plot based on the table. Then we join these points with a curve, and this will be the graph of y equals -x squared minus 4x plus 5. So from here, what observation can you see from the graph? So this dotted line will be the line of symmetry. The equation of this line is x equals -2 because it passed through the value here, -2. Alright, so we can say that the graph is symmetrical about to the line x equals -2. The next point we can say is that the graph intersects the x-axis at 2 points. The first point is -5, 0, which is this point, and 1, 0, which is this point. Next, we can also say that the graph intersects the y-axis at 0, 5. Right, so this is the point, 0, 5. We can also say that the point -1, 9 is the maximum point of the graph. So where is the point? This is the point, -2, 9. Okay, so last point we can mention is that the graph is in the shape of a parabola. So this is a parabola shape and it opens downwards. Now let's discuss the properties of quadratic graphs, which is in general form of y equals ax squared plus bx plus c. A quadratic graph is in the shape of parabola. So it can be in this case where when a is greater than 0 or when a is positive, then the graph will curve upwards or a smiley face. Number 2, it has a lowest point called the minimum point. So this will be the minimum point. It can be also in this shape where when a is less than 0 or the a is a negative value, then the graph curves downwards or a sad face. It has also a highest point called the maximum point. So this is the maximum point. Either it is a positive value or negative value of a. For both cases, the smaller the numerical value of a, the wider the graph opens. These points are called the y-intercepts. The graph cuts the y-axis at y-intercept. The coordinates of y-intercept is 0, c, which means the x-coordinate of the y-intercept is 0. To find the value of c, let x equal 0, then solve the equation. These 2 points are called the x-intercepts. The graph may cut the x-axis at 2 points, 1 point, or no point. This point or points is or are called the x-intercept with the coordinates of p0 and q0, where the y-coordinate of the x-intercept is 0. To find the value of P and Q, let y equals 0, then solve the equation. P and Q are called the roots of the solution or the solution of the equation. So these dotted lines are called the line of symmetry. The graph is symmetrical about the line of symmetry with the equation of x equals P plus Q over 2. We have just discussed all the properties of quadratic graphs. Now, let's learn how to sketch quadratic graphs in the form of y equals ax squared plus bx plus c. Example 3. Sketch the graph of y equals 2x squared plus 5x minus 12. Label your graph fully, marking the important points. So here's the solution. To sketch the graph, there are a few steps that we need to follow. Given y equals 2x squared plus 5x minus 12, step number 1, find the x-intercepts. To find the x-intercepts, let y equals 0. Hence, 0 equals 2x squared plus 5x minus 12. Then we solve this equation by factorizing it. 0 equals double bracket x, and times 2x we get 2x squared. 4 times 3 we get 12, and I'll put a plus and minus here so that I will have 8x minus 3x. I will get 5x. So from here, two numbers multiplied together we get a 0. Hence it will be either x plus 4 equals 0 or 2x minus 3 equals 0. Then we solve these two equations separately. X equals negative 4 or x equals 3 over 2. Or we can write it in the proper fraction, which is 1.5. Now we can draw the x-axis. So this is a smiley face because the coefficient of the x squared is a positive number, which is positive 2. Then this point will be negative 4, 0. And this point will be 1.5, 0. So these two are the roots of the equation. Next, step number 2, find the turning point. So for this case, the turning point is a minimum point. So to find the turning point, the x-coordinate will be adding the two roots then divide by 2 because it is at the middle of the two roots. Hence, for this case, it's negative 4 plus 1.5 divided by 2, and we get negative 5 over 4 or negative 1.25. Then we find the y-coordinate of the turning point. So just substitute x equals negative 5 over 4 into the equation. We have 2 times negative 5 over 4 squared plus 4 times negative 5 over 4 minus 12. Calculate the value, we get negative 13 and 708. So this will be our minimum point, and the coordinates is negative 1.25, negative 13, 708. Step number 3, find the y-intercept. To find the y-intercept, we let x equals 0. So the equation is y equals negative 12. So from here, I can start to draw my y-axis, and this y-intercept will be 0, negative 12. Step number 4, draw the line of symmetry. So this will be the line of symmetry with the equation of this line x equals negative 1.25. Step number 5, label the graph. So this graph is y equals 2x squared plus 5x minus 12. Now, let's try this example yourself. Sketch the graph of y equals negative 2x squared plus 8x plus 24. Label your graph fully, marking the important points. You can pause the video and try to draw it yourself. Alright, so here's the solution. Given the equation, y equals negative 2x squared plus 8x plus 24. So step number 1, we find the x-intercepts. We let y equals 0. the equation becomes 0 equals negative 2x squared plus 8x plus 24. After that, we can factorize negative 2. We have 0 equals negative 2 bracket x squared minus 4x minus 12. Then we can start to factorize. Double bracket here. X times x, we get x squared. 2 times 6, we get 12. The sign positive and negative in this way because we will get negative 6x plus 2x, which is negative 4x. Hence, x plus 2 equals 0 or x minus 6 equals 0. The roots will be x equals negative 2 or x equals 6. So for this case, we have found two roots. Then we can start to sketch a graph. First, draw the x-axis. So for this case, this is a set face curve downwards because the coefficient of the x squared is a negative number, which is negative 2. Then this is the root. The first root is negative 2, 0. And the second root is 6, 0. Next, step number 2, we find the turning point. So for this case, this is a maximum point. The x-coordinate for this turning point will be adding the two roots together divided by 2. So for this case, it's negative 2 plus 6 divided by 2. We get 2. Then we calculate the y-coordinate of this turning point. Just substitute x equals 2 into the equation. We will get negative 2 times 2 squared plus 8 times 2 plus 24. Calculate the value. The value is 32. Hence, for this maximum point, the coordinate is 2, 32. Next, step number 3. Find the y-intercept. To find the y-intercept, we let x equal to 0, hence y equals 24. So now we know this value of y-intercept. I can draw the y-axis, which is at this location, and this value will be 0, 24. Next, step number 4, draw the line of symmetry. So for this case, this dotted line will be the line of symmetry with the equation of x equals 2. Step number 5, label the graph. So this graph is y equals negative 2x squared plus 8x plus 24. Now, let's discuss quadratic function in completing the square form. Quadratic function can be expressed in completing the square form, which is y equals a bracket x minus b squared plus c, where a, b, and c are constant that can affect the shape of the quadratic graph. First question, how constant a can affect the graph? So let's see a few examples here. The basic quadratic function is y equals x squared. So if you want to plot this graph, this is how it looks like. Right? So it is a smiley face bending outwards. So what if this graph is multiplied by 2, which it becomes y equals 2x squared? So this is how the graph looks like. Now I increase the value of a, which becomes 3. Y equals 2x squared. So how will be the graph look like? So this will be the graph look like when y equals 3x squared. So as you can see, when we increase the value of a, the width of the graph gets narrower. Now, what about if I decrease the value of a, which y equals half x squared? This will be the graph it looks like, y equals half x squared. How about y equals to 1/3 x squared? This will be how it looks like when y equals 1/3 x squared. So from here are a few observations that we can see. Number 1, the greater the value of a, the narrower the graph. What is the reason? This is because y changes faster when the value of a is greater. Number 2, the smaller the value of a, the wider the graph. So what's the reason? Because now y changes slower when the value of a is smaller. So the conclusion that we can make from here is that The constant a determines the width of the graph. Now, let's consider the negative value of a. For example, y equals negative x squared. So this is how it looks like when y equals negative x squared. What about y equals negative 2x squared? So this is how it looks like when y equals negative 2x squared. And when y equals negative 3x squared, this will be the graph. Next, what about if I decrease the absolute value of a? For example, y equals negative half x squared. So this will be how it look like when y equals negative half x squared. What about y equals negative 1/3 x squared? This is how it look like when y equals negative 1/3 x squared. So from a few examples here are a few observations that we can see. Number one, the greater the absolute value of a, the narrower the graph. So take note the phrase absolute value, which it means we ignore the negative sign. Alright, so what's the reason when the greater the absolute value of a, the narrower the graph? It is very similar with the previous example because y changes faster when the absolute value of a is greater. Number 2. The smaller the absolute value of a, the wider the graph. The reason is because y changes slower when the absolute value of a is smaller. The conclusion that we can make from here is that the absolute value of a determines the width of the graph. Now the next question, how constant c can affect the graph? So here is an example. We start with the basic graph y equals x squared. This is how it looks like when y equals x squared. Now if I modify this equation, which becomes y equals x squared plus 2. So what it means is that the original graph y equals x squared is shifted 2 units upwards, where the y-intercept here now equals 2. How about y equals x squared plus 5? So again, it means that the whole graph of y equals x squared shift 5 units upwards. So we come here. This is the graph of y equals x squared plus 5. Now how about the negative value of c, which example y equals x squared minus 2. So a similar concept, it means that the basic graph y equals x squared shift 2 units downwards here, from 0 becomes negative 2. Similarly, when y equals x squared minus 5, so this graph y equals x squared shifted 5 units downwards at this point from 0 to negative 5. So the observation that we can see from here is, number 1, when the value of c is positive, the graph moves upwards direction. The reason is because each value of y in y equals x squared is added with the constant value of c. Next, when the value of c is negative, the graph moves downward direction. The reason is because each value of y in y equals x squared is subtracted with the constant value of c. The conclusion that we can make from here is that the constant c determines the movement of the graph in vertical direction. Now, let's consider the set phase case, or the value of a is a negative value. So for example, y equals negative x squared. So this is how it looks like when y equals negative x squared. As you can see, the curve bends downward direction and the maximum point touches the origin. So what if y equals negative x squared plus 2? So it is similar concept with the previous case where the curve moves 2 units to the vertical direction and from 0 to 2. How about y equals negative x squared plus 5? So the graph moves 5 units upwards from 0 to 5. What if it is a negative number, which is y equals negative x squared minus 2? So it means that the curve moves 2 units downwards, and the maximum point here is negative 2. Similarly, when y equals negative x squared minus 5, then this will be the graph where it moves 5 units downwards. So the observation that we can see from these few examples is, number 1, when the value of c is positive, the graph moves upwards direction. The reason is because each value of y in y equals negative x squared is added with the constant value of c. Number 2, when the value of c is negative, the graph moves in downward direction. The reason is because each value of y in y equals negative x squared is subtracted with the constant value of c. So the conclusion that we can make from here is that the constant c determines the movement of the graph in vertical direction. And as you can see from here, this exact same concept applies for negative graphs. Now the next question, how constant b can affect the graph? Let's watch how the graph changes when b changes. We start from the basic graph y equals x squared. So again, to sketch the graph, this is how it looks like. It is a smiley face. The minimum point touches the origin 0, 0. So if I modify this equation, which becomes y equals x minus 2 square, so you see that this graph moves 2 units to the right, and the minimum point will be 2. What if y equals x minus 5 square? Then this is how it looks like. The minimum point touches at x equals 5. What if y equals x plus 2 square? So this is y equals x plus 2 square, where the minimum point touches x equals negative 2. What if y equals x plus 5 square? This is how it looks like when y equals x plus 5 square, where the minimum point touches x equals negative 5. You might be wondering, what if this is minus 2, but this will be positive 2? When minus 5, this is positive 5, but when it's plus 2, this is negative 2, this is plus 5, this is negative 5. So here is the explanation. The observation that we can see is when the value of b is negative, the graph moves to the right. So here's the reason. Because when y equals to 0, then 0 equals x minus b squared. That means x minus b equals 0, so x equals b. Minimum point from y equals x squared, originally at 0, 0, changes to 0b when y equals x minus b squared. So this explains why when y equals x minus b squared, it moves b units to the right. So similarly, the second observation that we can see from here is when the value of b is positive, the graph moves to the left. So the reason is because when y equals to 0, then the equation becomes 0 equals x plus b squared, which means x plus b equals to 0, then x equals negative b. So this means that the minimum point from y equals x squared, originally at 0, 0, changes to 0, negative b when y equals to x plus b squared. So the conclusion that we can make from here is that the constant b determines the movement of the graph in horizontal direction. Now let's consider the negative case. We start from y equals negative x squared. So this is how it looks like when y equals negative x squared. So when the equation is modified to become y equals negative bracket x minus 2 square, so it will move 2 units to the right. The maximum point here will touch the point at x equals 2. Similarly, When y equals negative bracket x minus 5 square, then the graph moves 5 units to the right, where the maximum point touches the x-axis at x equals to 5. Now I change the b to become positive value when y equals negative bracket x plus 2 square, then the graph moves 2 units to the left and the maximum point touches the x-axis at x equals negative 2. Similarly, when y equals negative bracket x plus 5 square, then the graph moves 5 units to the left where the maximum point touches the x-axis at x equals negative 5. So the observation that you can see is when the value of b is negative, the graph moves to the right. So here is the reason. When y equals 0, then the equation becomes 0 equals negative bracket x minus b square, which means x minus b equal to 0, then x equals to b. So the maximum point from y equals negative x square, originally at 0, 0, changes to 0b when y equals negative bracket x minus b square. Observation number 2. When the value of b is positive, the graph moves to the left. Here is the reason. When y equals 0, the equation becomes 0 equals negative bracket x plus b square, which means x plus b equals to 0 and x equals negative b. Hence, the maximum point from y equals negative x square, originally at 0, 0, changes to 0, negative b when y equals negative bracket x plus b square. So here is the conclusion that we can make from here. The constant b determines the movement of the graph in horizontal direction. Now let's make a summary on what we have discussed so far. Quadratic function can be expressed in completing the square form y equals a bracket x minus b square plus c, where a, b, and c are constants that can affect the shape of the quadratic graph. The value of a determines the width of the graph. The greater the absolute value of a, the narrower the graph. The smaller the absolute value of a, the wider the graph. So here is the graphs for positive case and here is the graphs for the negative case. When a is greater than 0 or a is a positive number, the graph curves up or it is a smiley face. On the other hand, when a is less than 0 or a is a negative number, the graph curves down or it is a sad face. Next, the constant c determines the movement of the graph in vertical direction. So this is the positive case and this is the negative case. When c is greater than 0 or c is positive, the graph moves up. When c is less than 0 or c is negative, the graph moves down. The constant b determines the movement of the graph in horizontal direction. So this is the positive case and this is the negative case. When b is less than 0 or b is negative, the graph moves to the right. When b is greater than 0 or b is positive, the graph moves to the left. Now, let's observe how the graph changes when the values of a and b changes. So when y equals x squared, this is how the graph looks like, where the minimum point is 0, 0. Now when y equals x minus 2 squared, then from this original graph, it moves 2 units to the right, and the minimum point touches the x-axis at x equals 2. Hence, the coordinates of the minimum point will be 2, 0. When y equals x minus 2 square plus 3, so the graph will move 2 units to the right and 3 units to the top. where the coordinates of the minimum point is 2, 3. Notice that the value of B and the value of C can determine the coordinates of the minimum point. This is the line of symmetry, which is x equals 2. Now, let's observe for the negative case, y equals negative x squared. So this is the graph of y equals negative x squared, where the maximum point is 0, 0. Now, when the equation becomes y equals negative bracket x minus 2 square, then the graph moves 2 units to the right, and the maximum point, now the coordinates will be 2, 0. Next, when y equals negative bracket x minus 2 square minus 3. So start from the original graph y equals negative x square. First, it moves 2 units to the right. This will be 2 and 3 units to the bottom. And this is the coordinates of the maximum point, which is 2, negative 3. Again, notice the coordinates of the maximum point with the value of B and C. This is the line of symmetry, which is x equals 2. So from these examples, when a quadratic function is expressed in complete the square form, y equals a bracket x minus b square plus c, we can obtain the coordinates of maximum or minimum point, or in general, turning point, directly from the equation. The maximum, minimum, or turning point is B, C. And the line of symmetry is x equals B. Remember to switch the sign of B when you want to write down the maximum or minimum or the turning point. Now we can learn how to sketch the quadratic function in the form of a bracket x minus b square plus c. Example 4. Given the following quadratic functions: a, y equals 2 bracket x plus 1 square plus 3. b, y equals 2 bracket x minus 2 square minus 18. And c, y equals negative 3 bracket x plus 2 square. These functions can be drawn on a graph paper. For each function, number 1, state the coordinates of stationary point. Number 2, is the stationary point a minimum point or maximum point? Give a reason for answer. Number 3, write down the line of symmetry of the graph. Number 4, determine the y-intercept of the graph. And number 5, determine the x-intercept of the graph, if any. Number 6, hence sketch the graph. So here's the solution. We will answer all these questions for each of the quadratic function. For a, y equals 2 bracket x plus 1 square plus 3. So from this equation, the a is 2, the b is 1, and the c is 3. So for number 1, the coordinates of the stationary point will be negative 1, 3. Number 2, since the a is positive number, then it will be a minimum point. Number 3, the line of symmetry will be x equals negative 1. Number 4, to find the y-intercept, we let x equal to 0, then the equation becomes y equals 2 bracket 0 plus 1 square plus 3. We calculate it, will get 5. Hence the coordinates of the y-intercept is 0, 5. Number 5, to find the x-intercepts, we let y equal to 0, hence the equation becomes 0 equals 2 bracket x plus 1 square plus 3. So x plus 1 square equals negative 3 over 2. But from here, there is no solution because a square number cannot be a negative number. Hence, there is no x-intercept. Number 6, now we can start to sketch the graph. So this is my x-axis. Since there is no x-intercept, then it will be above the x-axis, where the minimum point coordinates will be negative 1, 3, and the y-intercept will be 0, 5, where this dotted line is the line of symmetry. Equation is x equals negative 1. Lastly, label the graph. So y equals 2 bracket x plus 1 square plus 3. For b, the equation is y equals 2 bracket x minus 2 square minus 18. So from here, the a is 2, the b is 2, and the c is negative 18. So answer number 1, the stationary point coordinates will be 2, negative 18. Number 2, since a is greater than 0 or a is a positive number, then it is a minimum point. Number 3, the line of symmetry will be x equals 2. Number 4, to find the y-intercept, we let x equal to 0. Hence, the equation becomes y equals 2 bracket 0 minus 2 square minus 18. Calculate, we get negative 10. Hence, the y-intercept coordinates will be 0, negative 10. Number 5, to determine the x-intercepts, we let y equal to 0. Then the equation becomes 0 equals 2 bracket x minus 2 square minus 18. So x minus 2 square equals to 9. X minus 2 equals plus minus square root of 9, which is x minus 2 equals to 3, or x minus 2 equals negative 3. Hence, the roots will be x equals 5 or x equals negative 1. Now we can start to sketch a graph. Start with the x-axis. It is a smiley face with two roots. The first root is negative 1, 0, and the second root will be 5, 0. This will be the minimum point with the coordinates of 2, negative 18. This is the y-axis, and this point will be the y-intercept with the coordinates of 0, negative 10. This dotted line is the line of symmetry with the equation of x equals 2. Lastly, let's label the graph. This graph is y equals 2 bracket x minus 2 square minus 18. Next, for c, the equation is y equals negative 3 bracket x plus 2 square. So first we identify the value of a, b, and c. So for this case, a is negative 3, b is negative 2, and there is no c here, which means c equals 0. So answer number 1, the coordinates of the stationary point will be negative 2, 0. Number 2, since a is less than 0 or a is a negative number, then it is a maximum point. Number 3, so the line of symmetry will be x equals negative 2. Number 4, to determine the y-intercept, we let x equal to 0. Then equation is y equals negative 3 bracket 0 plus 2 square, which is negative 12. Hence, the coordinates of the y-intercept is 0, negative 12. Number 5, again, to determine the x-intercept, we let y equal to 0. Then the equation becomes 0 equals negative 3 bracket x plus 2 square, which means x plus 2 square equal to 0. X plus 2 is 0. Then x equals negative 2. So the coordinates of the x-intercept will be negative 2, 0. we only have one x-intercept, and the maximum point and the x-intercept are actually the same point. So now we can start to sketch the graph. We start with the x-axis. Then this is a surface touching one point at the x-axis, and this point is the maximum point and also the x-intercept with the coordinates of -2, 0. So this will be the y-intercept. Then we draw the y-axis. This will be the line of symmetry with the equation of x equals -2. Lastly, label the graph. So this graph is y equals -3 bracket x plus 2 squared. Now let's see more examples. And this round, I want you to try it yourself. Given the following quadratic functions: a, y equals -3 bracket x minus 2 squared minus 4. b, y equals -2 bracket x plus 2 squared plus 8. c, y equals 5 bracket x minus 6 squared. For each function, number 1, state the coordinates of stationary point. Number 2, is the stationary point a minimum point or maximum point? Give a reason for your answer. Number 3, write down the line of symmetry of the graph. Number 4, determine the y-intercept of the graph. Number 5, determine the x-intercepts of the graph if any. Number 6, hence sketch the graph. You can pause the video and try to do it yourself. Alright, so here is the solution. For A, the equation is y equals -3 bracket x minus 2 squared minus 4. The value of A is -3, B is 2, and C is -4. Number 1. The coordinates of the stationary point will be 2, -4. Number 2. Since A is less than 0 or A is a negative number, then the stationary point is a maximum point. Number 3. The equation of line of symmetry is x equals 2. Number 4. To determine the y-intercept, we let x equals 0. Then the equation becomes y equals -3 bracket 0 minus 2 squared minus 4. We calculate the value, we get -16, which means the y-intercept coordinate will be 0, -16. Number 5. To find the x-intercept, we let y equal to 0. Hence, the equation becomes 0 equals -3 bracket x minus 2 squared minus 4. X minus 2 squared equals -4/3. But there is no solution because a square number cannot be a negative number. Hence, there is no x-intercept. Alright, now we can start to sketch the graph. We start with the x-axis. So since there is no x-intercept and it is a surface, then the graph will be below the x-axis. This is the maximum point with the coordinates of 2, -4. This is the y-axis with the y-intercept coordinates of 0, -16. This will be the line of symmetry with the equation of x equals 2. And lastly, label the graph. This is the graph of y equals -3 bracket x minus 2 squared minus 4. For part B, the equation is y equals -2 bracket x plus 2 squared plus 8. The A is -2, the B is -2, and the C is 8. So number 1, the coordinates of the stationary point will be -2, 8. Number 2, since the A is less than 0 or the A is a negative number, then the stationary point will be a maximum point. Number 3, the equation of the line of symmetry will be x equals -2. Number 4, to determine the y-intercept, we let x equal to 0. Hence, the equation becomes y equals negative 2 bracket 0 plus 2 square plus 8. Calculate the value, we get 0. Hence, the y-intercept is at the origin 0, 0. Number 5. To determine the x-intercepts, we let y to be 0. Hence, the equation becomes 0 equals negative 2 bracket x plus 2 square plus 8. Hence, x plus 2 square equals 4, or x plus 2 equals plus minus square root of 4. Then we solve it separately. X plus 2 equals to 2, or x plus 2 equals to negative 2. X equal to 0, or x equals to negative 4. So from here we can see that the roots is the same. One of the roots is the same point with the y-intercept. Alright, now we can start to sketch the graph. Start with the x-axis. This is a surface with two roots. The first root is negative 4, 0, and the second root is 0, 0. This is the maximum point with the coordinates of negative 2, 8. And this is the y-axis. It must pass through the second root because it is the same point. The y-intercept is the same point with one of the roots. This is the line of symmetry with the equation of x equals negative 2. And lastly, label the graph. This is the graph of y equals negative 2 bracket x plus 2 square plus 8. For C, the equation is y equals 5 bracket x minus 6 square. So the A value is 5, B is 6, and since there is no C, that means C equals to 0. Number 1, the coordinates of the stationary point is 6, 0. Number 2, since A is positive, then the stationary point is a minimum point. Number 3, the equation of the line of symmetry is x equals to 6. Number 4, to determine the y-intercept, we let x equal to 0. Hence, the equation becomes y equals to 5 bracket 0 minus 6 square. Hence, it is 180, which means the coordinates of the y-intercept is 0, 180. Number 5. To determine x-intercept, we let y equal to 0. Hence, the equation becomes 0 equals 5 bracket x minus 6 square, or x minus 6 square equal to 0, or x minus 6 equal to 0, which means x equal to 6. Hence, the coordinates of the x-intercept is 6, 0. Notice that there is only one root, and the minimum point and the x-intercept are the same point. Alright, so let's look at it. This is the coordinates of the minimum point, 6, 0, and this is also the x-intercept, 6, 0. Alright, now we can start to sketch the graph. We start with the x-axis. This is a smiley face and touch the x-axis at one point, which is the minimum point. Coordinates is 6, 0. And then we draw the y-axis. This is the x in the y-intercept. Coordinates is 180. Right, so this is the line of symmetry with the equation of x equals to 6. Alright, lastly, we will label the graph y equals to 5 bracket x minus 6 squared. Quadratic graph of y equals x minus p times x minus q. Consider the quadratic equation y equals x minus p times x minus q, where p and q are constants. When y equals to 0, then 0 equals x minus p times x minus q. So from this equation, there are two numbers multiplied together and produce 0. Hence, either x minus p equals 0 or x minus q equals 0. X equals p or x equals q. X equals p and x equals q are the roots of the equation 0 equals x minus p times x minus q, which are the x-intercepts of the quadratic graph. Hence, now let's draw the graph where the x-axis, this is the smiley face because the coefficient of the x squared is positive. Then this is the roots p and q. X equals p plus q over 2 is the line of symmetry of the graph. Hence, this dotted line is the line of symmetry, and this point is p plus q over 2. The equation of the line of symmetry is x equals p plus q over 2. When x equals 0, then the equations become y equals 0 minus p times 0 minus q, which is pq. So y equals pq is the y-intercept of the quadratic graph. So in general, let's say this is the y-axis. This point will be pq. This is the minimum point of the graph. When x equals p plus q over 2, then the equation becomes y equals p plus q over 2 minus p times p plus q over 2 minus q, which will get q over 2 minus p over 2 times p over 2 minus q over 2. Simplify, we get negative p over 2 minus q over 2 square. So the coordinates of the minimum point will be p plus q over 2 and negative bracket p over 2 minus q over 2 square. Now, let's consider negative quadratic equation y equals negative bracket x minus p times x minus q. When y equals 0, then the equation becomes 0 equals negative bracket x minus p times bracket x minus q. Now from here, we can see that two numbers multiply together and produce 0. Hence, either x minus p equals 0 or x minus q equals 0, which means x equals p or x equals q. So this x equals p and x equals q are the roots of the equation 0 equals negative bracket x minus p times bracket x minus q, which are the x-intercepts of the quadratic graph. So again, let's sketch the graph. So this is the x-axis. Since the coefficient of x squared is negative, hence it is a sad face, so it bend downwards. So this point is p and this is q, the roots of the equation. So x equals p plus q over 2 is the line of symmetry of the graph. Hence this dotted line is the line of symmetry. This point is p plus q over 2, and the equation of the line of symmetry is x equals p plus q over 2. When x equals 0, then the equation becomes y equals negative bracket 0 minus p times bracket 0 minus q. Simplify, we get negative pq. So y equals negative pq is the y-intercepts of the quadratic graph. So let's draw the y-axis, and this point, negative pq, will be the y-intercept of the curve. This is the maximum point. So when x equals p plus q over 2, then the equation becomes y equals negative bracket p plus q over 2 minus p times bracket p plus q over 2 minus q. Then it becomes negative bracket q over 2 minus p over 2 times bracket p over 2 minus q over 2. Simplify, we get p over 2 minus q over 2 square. Hence, the coordinates of the maximum point is p plus 2 over 2, p over 2 minus q over 2 square. How about when q equals p? Then the equation becomes y equals x minus p times x minus p, which is y equals x minus p square. So when y equals 0, then the equation becomes 0 equals x minus p square, which is 0 equals x minus p, and hence x equals p. So x equals p is the root of the equation 0 equals x minus p square, which is the x-intercept of the quadratic graph. Notice that for this case, we only have one real root. Hence, when I want to sketch the graph, this is the x-axis, and this curve is a smiley face because the coefficient of the x squared is positive. This point is P, which is the x-intercept of the graph. So from this graph, we can see that x equals P is the line of symmetry of the graph. So this dotted line is the line of symmetry with the equation x equals P. Next, when x equals 0, then the equation becomes y equals 0 minus p squared, which is p squared. Hence, y equals p squared is the y-intercept of the quadratic graph. So we can start to draw the y-axis, and this point is the y-intercept with the value of p squared. This is the minimum point. From this graph, we can see that the coordinates of this minimum point is p0. Similarly, for negative quadratic equation, y equals negative bracket x minus p squared, where y equals 0, then the equation becomes 0 equals negative bracket x minus p squared, which x minus p squared equals 0, hence x equals p. So x equals p is the root of the equation 0 equals negative bracket x minus p squared, which is the x-intercept of the quadratic graph. And again, for this case, we only have one real root. So to sketch the graph, we start with the x-axis, and this graph is a set face because the coefficient of the x squared is a negative number, so it will be bending downwards. This point is point P, which is the x-intercept of the graph. So x equals P is the line of symmetry of the graph. So this dotted line will be the line of symmetry with the equation x equals P. Next, when x equals 0, then the equation becomes y equals negative bracket 0 minus p squared, which is negative p squared. Y equals negative p squared is the y-intercept of the quadratic graph. Hence, we can draw the y-axis, and this point is the y-intercept with the value of negative p squared. This is the maximum point. From this graph, we can see that the coordinates is p0. Now, let's look at example 5. Sketch the graph of y equals x minus 2 times x plus 3, indicating clearly its intercepts with the axis. Find the coordinates of its turning point. So here's the solution. Step number 1, we will find the x-intercepts by letting y equals 0. So when y equals 0, then the equation becomes 0 equals x minus 2 times x plus 3. So x minus 2 equals 0, or x plus 3 equals 0. Then we solve these two equations, x equals 2 or x equals negative 3. So these two are the roots of the equation. Hence, now we can start to sketch the graph. We start from the x-axis, and for this case, this is a smiley face because the coefficient of the x squared is 1. So this point is negative 3, the first root of the equation, and this is the second root, x equals 2. The next step number 2, we will find the line of symmetry. So the line of symmetry is in between the two roots. So x equals 2 plus negative 3 over 2, which will get x equals negative half. So this dotted line will be the line of symmetry with the equation of x equals negative half. So this point will be negative half. Next step number 3, draw the y-axis. So for this case, the y-axis will be in between negative half and 2. So I will draw the y-axis at around this location. The next step number 4, find the y-intercept. To find the y-intercept, we'll let x equal 0. Then the equation becomes y equals 0 minus 2 times 0 plus 3, which is negative 6. Hence, this point will be negative 6. Next step number 5. Find the turning point. For this case, it is a minimum point because it is a smiley face. To find the minimum point, the x-coordinate of the minimum point is -half. They will substitute it into the equation. They will get the y equals -half minus 2 plus -half plus 3. Then we get -6 and 1/4. So the coordinates of the minimum point will be -half and -6 and 1/4. Finally, label the graph. Equation is y equals x minus 2 times x plus 3. Now, you can try this example yourself. Sketch the graph of y equals negative bracket x plus 1 times bracket x plus 5, indicating clearly its intercepts with the axis. Find the coordinates of its turning point. You can pause the video and try to do it yourself. So here's the solution. Step number 1. Find the x-intercepts. To find the x-intercepts, let y equal to 0. Then the equation becomes 0 equals negative bracket x plus 1 times bracket x plus 5, which means x plus 1 equals 0 or x plus 5 equals 0. Then we solve these two equations, which we get x equals -1 or x equals -5. So these two numbers are the roots of the equation. Then we can start to sketch the graph. First we draw the x-axis, and then for this case it is a set face or curve downwards because the coefficient of the x square is negative. This point is -5 and this point is -1. Next, step number 2. Find the line of symmetry. So the line of symmetry will be in the middle of the two roots. So for this case is x equals -1 plus -5 divided by 2. We get x equals -3. So this dotted line will be the line of symmetry, and the equation of the line of symmetry is x equals -3, where this point is -3. Step number 3. Draw the y-axis. So for this case, the y-axis will be after the -1. Hence, this will be the y-axis. Then step number 4, we find the y-intercept. So to find the y-intercept, we let x equals 0. Then the equation becomes y equals negative bracket 0 plus 1 times bracket 0 plus 5, and the value is -5. So this point will be -5. Step number 5, find the turning point, which for this case, the turning point is a maximum point. The x-coordinate of the turning point is -3, hence we let x equals -3. Substitute into the equation, we get y equals negative bracket -3 plus 1 times bracket -3 plus 5. Calculate the value, we get 4. Hence, this is the maximum point with the coordinates of -3, 4. And finally, label the graph y equals negative bracket x plus 1 times bracket x plus 5. Alright, let's look at example 6. This is for the case where p equals q. Sketch the graph of y equals bracket 3x minus 5 square, indicating clearly its intercepts with the axis. Determine the nature and the coordinates of its turning point. So here is the solution. Step number 1, we find the x-intercept. So to find the x-intercept, we let y equals 0. Then the equation becomes 0 equals bracket 3x minus 5 square, which means 3x minus 5 equals 0. They will solve this equation, 3x equals 5 and x equals 5 over 3. Or you can change it into a proper fraction, which is 1 and 2/3. So for this case, as you can see from here, we only have one root. Then we want to start to draw the graph. We draw the x-axis, and for this case it is a smiley face because the coefficient of the x squared is positive. As you can see from here, when you draw this curve, it only touched the x-axis at one point, and this point is 1 and 2/3. Next step, step number 2, we find the line of symmetry. So for this case, this dotted line is the line of symmetry which passed through the point 1 and 2/3. Hence, the equation of this line of symmetry is x equals 1 and 2/3. So the line of symmetry is x equals 1 and 2/3. Next step, step number 3. We draw the y-axis. So for this case, the y-axis will be at the left hand side of the point 1 and 2/3. So I will draw the y-axis around this location. Then the next step, I want to find the y-intercept, where I will let x equal to 0. The equation becomes y equals bracket 0 minus 5 square, which we get 25. Hence, this point will be 25. Step number 5. Find the turning point. So, as you can see from here, this point is also the turning point. The root is also the turning point, and this is a minimum point. So, the coordinates of the minimum point will be 1 and 2/3, 0. And lastly, label the curve y equals bracket 3x minus 5 square. So this will be the curve for the equation of y equals bracket 3x minus 5 square. Alright, now you can try this example yourself. Sketch the graph of y equals negative bracket 2 minus 7x square, indicating clearly its intercepts with the axis. Determine the nature and the coordinates of its turning point. You can pause the video and try to do it yourself. Alright, so here's the solution. Step number 1, we find the x-intercepts by letting y equals 0. Hence, the equation becomes 0 equals negative bracket 2 minus 7x squared. Then solve this equation. 2 minus 7x equals 0. 2 equals 7x. Hence, x equals 2 over 7. So as you can see, for this case, we only have one real roots. And now we can start to sketch the graph. This is the x-axis. It is a set phase because the coefficient of the x squared for this example is negative number. And this curve touches the x-axis at the value of 2 over 7. Step number 2, we find the line of symmetry. So this dotted line is the line of symmetry and passes through the point 2, 7, 2 by 7. Hence, the equation of this line of symmetry is x equals 2 over 7. Next step, step number 3. We draw the y-axis. So for this case, the y-axis will be at the left hand side of the point 2, 7, 2 over 7. Hence, this is the y-axis. And then the next step, we want to find the y-intercept. We let x equal to 0. Then the equation becomes y equals negative bracket 2 minus 0 square. Hence, we get negative 4. So this point, the y value is negative 4. Step number 5, we find the turning point. So where is the turning point? This point will be the turning point, which is also the roots of the equation. So for this case, the nature of the turning point is a maximum point. And the coordinates of the maximum point will be 2 over 7, 0. And lastly, label the curve y equals negative bracket 2 minus 7x squared. Now, let's look at one more example for quadratic graph of y equals x minus p times x minus q. So example 7, given this diagram, the diagram shows the quadratic graph. Determine A, the line of symmetry, B, the equation of graph, C, the coordinates of the minimum point. And here is the solution. For A, to find the line of symmetry, so let's draw the line first. This is the dotted line, and it is in between negative 5 and 1. So to find the x value, it is x equals negative 5 plus 1 over 2, and we get negative 2. So this point is negative 2, and the equation of the line of symmetry is x equals negative 2. Then for B, the equation of the graph, so we have two roots here, which is x equals -5 or x equals to 1. So after that, we reverse the process from solving the equation become forming the equation. So x plus 5 equals 0 or x minus 1 equals 0. We combine these two factors together, x plus 5 times x minus 1 equals 0, and the equation of the curve will be y equals k bracket x plus 5 times bracket x minus 1, where k is a constant that we need to find. So let's look at the y-intercept here, this point. So the coordinates of the y-intercept is 0, -10, which means when x equals 0, then y equals -10. So we substitute these two values into the equation, y is -10 and x is 0. The equation becomes -10 equals k times bracket 0 plus 5 times bracket 0 minus 1, which is -5, k equals -10, hence k equals 2. So forming the equation, we get y equals 2 bracket x plus 5 times bracket x minus 1. We can expand the bracket, y equals 2 bracket x squared plus 4x minus 5. Expand again, we will have y equals 2x squared plus 8x minus 10. So this is the equation of the curve. Next, C. Find the coordinates of the minimum point. So this is the minimum point where the x coordinate is -2. So we substitute x equals -2 into the equation of the curve. Then we get y equals 2 bracket -2 plus 5 times -2 minus 1. We calculate everything, we'll get -18. Hence, coordinates of the minimum point will be -2, -18. Alright, now it's your turn to try this similar example yourself. Given this diagram, the diagram shows a quadratic graph. Determine A. The line of symmetry, B. The equation of the graph, and C. The coordinates of the maximum point. You can pause the video and try to do it yourself. Okay, so here's the solution. For A, to find the line of symmetry, so this total line will be the line of symmetry, and it is in the middle of the value of 2 and 4. Alright, so x equals 2 plus 4 over 2, which is 3. So this point is 3, and the equation of the line of symmetry is x equals 3. Next, for B, so for this case, we have two roots here, which is k equals 2 or k equals 4. Then x minus 2 equals 0 or x minus 4 equals 0. So we combine these two roots together, x minus 2 times x minus 4 equals to 0, and forming the equation y equals k bracket x minus 2 times bracket x minus 4, where k is a constant. Then we move on to look at the y-intercept of this graph. The coordinates of the y-intercept is 0, -24, which means when x is 0, then the y is -24. Then we substitute these two values into the equation. We will get -24 equals k bracket 0 minus 2 times bracket 0 minus 4. So 8k equals -24, then k is equal -3. So the equation of the curve will be y equals -3 bracket x minus 2 times x minus 4. We can expand the bracket, we will have y equals -3 times x squared minus 6x plus 8. Expand again, we will have y equals -3x squared plus 18x minus 24. So this will be the equation of the curve. And lastly, find the coordinates of the maximum point. So this is the maximum point. We know that the coordinates, the x coordinate of the maximum point is 3. So x equals to 3. Substitute into the equation. We'll have y equals -3 bracket 3 minus 2 times bracket 3 minus 4. Calculate everything, we have 3. Hence, the coordinates of the maximum point will be 3, 3. After learning how to sketch quadratic graphs, you may wonder how we can apply this knowledge in our daily life. In this section, we will discuss how we can apply quadratic graphs in three regions, which are business, engineering, and sports science with simple examples. So now, let's look at example 8. Given that the daily profit Y in dollars from the sales of a mobile phone can be represented by Y equals 350x minus x squared, where x is the number of the mobile phones manufactured in a day. A. Sketch the graph of Y equals 350x minus x squared, where x is greater or equal to 0. B. How many mobile phones must be manufactured in order to maximize the profit? How much is the maximum profit? C. What is the maximum number of mobile phones can be manufactured before loss will happen? So here's the solution. For A, we need to sketch the graph. So first we let y equal to 0. Then the equation becomes 0 equals 350x minus x squared. Factorize, we get 0 equals x bracket 350 minus x, which means x equal to 0 or 350 minus x equals 0. Then x equals 350. So you can start to sketch the graph. So this x-axis, it is a set phase because the coefficient of the x squared is negative. This point will be 0 and this point will be 250, which are the roots of the equation. Then since we have 0 here, we know that this is the y-axis. So this graph is y equals 250x minus x squared. So B, to find the maximum profit, we have to look at the maximum point. So first we have to find the line of symmetry. So this is the dotted line, and the line of symmetry is between 0 and 350. So x equals 0 plus 350 divided by 2, which is 175. So this point will be 175, and the maximum value of y will be when x is 175. So substitute x equals 175 into the equation. We will have y equals 350 times 175 minus 175 squared. Calculate the value, we have y equals 30,625. So this will be $30,625. So which means the maximum profit is $30,625. So see, to find what's the maximum number before loss will happen, we have to look at the second root, 350, because after 350, we can see that the curve go below the x-axis, which means we will have a negative profit or loss. Then the answer will be the maximum number of mobile phone can be manufactured before loss is 350. Now let's try this example 8 yourself. In a computer shop, the daily profit Y in dollars for selling X keyboards is given by the equation Y equals negative x squared plus 100x minus 900. A. Sketch the graph of Y equals negative x squared plus 100x minus 900 for x greater than or equals to 0. B. How many keyboards should be sold in order to have the maximum profit? What is the maximum profit? C. What is the minimum and maximum number of keyboards should be sold daily to keep the sale of keyboards profitable? You can pause the video and try to do it yourself. Alright, so here's the solution for A. To sketch the graph, first we let y to be 0 to find the x-intercept. So when y equals 0, then the equation becomes 0 equals negative x squared plus 100x minus 900. Simplify, we have 0 equals x squared minus 100x plus 900. Factorize, 0 equals x minus 10 times x minus 90. Then solve the two equations separately. X minus 10 equals 0 or x minus 90 equals 0, which means x equals 0 x equals 10 or x equals to 90. So these two are the roots of the equation. Hence, we can start to sketch the graph. We start with the x-axis. So the roots is 10 and 90. So this is a set phase curve because the coefficient of the x squared is negative. And we let y equals 0 to find the y-intercept. Then the equation becomes y equals negative 0 square plus 100 times 0 minus 900. Calculate, we have y equals negative 900. So we draw the y-axis, and this y-intercept will be negative 900. So this will be the curve for the equation y equals negative x squared plus 100x minus 900. Then move on to B. So first we want to find the line of symmetry in order to find the maximum profit. So this will be the line of symmetry, and the x coordinate of the x value for the line of symmetry is the middle of the roots, which is 10 and 90. Hence x is 10 plus 90 divided by 2, which will get 50. So this value will be 50. And we substitute x equals 50 into the equation y equals negative 50 squared plus 100 times 50 minus 900. Calculate, we get 1600. So it means that 50 keyboards should be sold to have maximum profit, and the maximum profit is $1,600. Alright, so this is 1,600. Then next one, C. What is the minimum point and maximum number of keyboards to be sold so that we will have profitable sale? Then we need to look at the roots, the 10 and the 90. So any number of keyboards sold less than 10 or greater than 90, they will have a loss, because from the graph we can see that these values are below the x-axis. Hence, the minimum of 10 and the maximum of 90 keyboards should be sold daily to keep the sale profitable. Now, let's look at example 8, which is engineering example. So we have this diagram. A cable is hung between two buildings at point A and point C. The height of each building is 90 meters. The arc ABC can be modeled by the equation y equals 2x squared minus 20x plus 90, where y is the distance between a particular point on the cable and the ground, which is the vertical distance to the ground. And x is the distance between that particular point on the cable and point A, which is the horizontal distance from point A. A. Represent the equation in the form of y equals a bracket x minus b squared plus c, which is the completing the square form. B. Hence, sketch the graph of the given equation. C. Find the value of h, the distance between the lowest point of the cable and the ground. D. Find the horizontal distance between point A and point C. So here's the solution. For A, the equation given is y equals 2x squared minus 20x plus 90. So we want to convert this equation into completing the square form. So first, make sure the coefficient of x squared is 1. So I factorize the 2 here. It becomes y equals 2 bracket x squared minus 10x close bracket and plus 90. So now we can perform the completing the square. We will get y equals 2 bracket x minus 5 squared minus 5 squared, then plus 90. Expand the bracket, we have y equals 2 bracket x minus 5 squared minus 50 plus 90, and it will become y equals 2 bracket x minus 5 squared plus 40. So this is in the completing the square form. Then we can start to sketch the graph for B. Then from the equation y equals 2 bracket x minus 5 squared plus 40, the minimum point is 540. So then we want to find the x-intercept, y equals 0. So the equation becomes 0 equals 2 bracket x minus 5 square plus 40. And we're trying to solve this equation. 2 bracket x minus 5 square minus equals negative 40, which is x minus 5 square equals negative 20. From here, as you can see, a square number should be a positive number, cannot be a negative number. Hence, for this case, there is no solution. Next, I want to find the y-intercept, so I will let x equals 0. Then the equation becomes y equals 2 bracket 0 minus 5 square plus 40. Calculate the value, we'll get y equals 90. And now we can start to sketch the graph. So this is the x-axis. So it will be a smiley face because the coefficient of x squared is positive. And it is above the x-axis because there is no solution. Then I can draw the y-axis. And this is the minimum point, 540. The y-intercept is 0, 90. And let's label the graph, y equals 2 bracket x minus 5 square plus 40. C, to find the value of h, so we look at the graph and locate where is the h. So this is the h. And from here, we can see that h equals 40. So the distance between the lowest point of the cable and the ground is 40 meters. So to find the horizontal distance between point A and point C, we need to know the x coordinates of point A and point C. So first, we let y equals to 90 because in these 2 points, point A and point C, they are 90 meters above the horizontal ground. So the equation becomes 90 equals 2 times x minus 5 square plus 40, which means 50 equals 2 times x minus 5 square, or x minus 5 square equals to 25. Hence, x minus 5 equals plus minus square root of 25. Then we calculate separately, x minus 5 equals negative 5, or x minus 5 equals to 5. Solve these two equations. X equals 0, which is the first point, point A, and x equals to 10, which is point C. And then we look at the graph. The origin is 0, and the point A is vertically above the origin. And this will be 10. C will be above the value of x equals 10. This will be the horizontal distance between point A and point C, and it is 10 units. So the distance between point A and point C is 10 meters. Now you can try this simple engineering example yourself. Given this diagram, the diagram shows the gate of a school which is built on the horizontal ground PQ. Arch ABC can be modeled by the equation y equals 1 plus 2x minus x squared, where point P is taken to be the origin, PQ is the x-axis, C is at the same level as A, and the unit length is meter. A. What is the height of AP? B. Find the distance of PQ. C. Given that point B is the highest point of the arch, what is the vertical height of this point to the ground? D. Sketch the graph of the arch ABC. You can pause the video and try to do it yourself. Alright, so here's the solution. So given that PQ is the x-axis, we can draw x-axis at PQ, and point P is the origin, so the y-axis will be somewhere here. Then we can look at the question, the height of AP. So since P is the origin, then we let x to be equals 0. The equation becomes y equals 1 plus 2 bracket 0 minus 0 square, which is 1. Hence, the height of AP equals 1 meter. For B, since C is at the same level as A, we let y equals 1. Then equation becomes 1 equals 1 plus 2x minus x squared. So 0 equals 2x minus x squared. Then we factorize 0 equals x bracket 2 minus x. So x equals 0 or 2 minus x equals 0. So x equals 0 is point A, and x equals 2, which is here, these two distance is 2 meters. So the distance between PQ is 2 meters. C. So this total line will be the line of symmetry of the arch ABC. And the x coordinate of B will be the middle of the 0 and 2. So which is 0 plus 2 divided by 2, we get 1. Hence the y coordinate will be y equals 1 plus 2 times 1 minus 1 square, which is 2. So this tells us the vertical height of B is 2 meters. And D, now we can start to sketch a graph. So this is the x-axis, this is the y-axis. This will be the arch, where this is point A, this is point B, and this is point C. This is the origin 0, and this is the y-intercept, which is 1. This is the line of symmetry, and the x value is 1. The y value is 2. This is the point C, which is horizontal distance is 2. And it is same level as point A. And this is the arc for the equation y equals 1 plus 2x minus x squared. Now, let's look at example 9, which is sport science example. Ali kicks a ball from point O on a horizontal field. The ball flies in a trajectory which can be represented by a quadratic function. It reaches its highest point 6 meters above the field and a horizontal distance 15 meters away from O. A. How far away from O will the ball land? B. Let O to be the origin, x meters be the horizontal distance of the ball from O, and y meters be the height of the ball above the field. If the equation of the flight of the ball is represented by the equation y equals k bracket x minus a times bracket x minus b, where k, a, and b are constants, determine the equation. C. Sketch the graph of the equation that is obtained from B. So here's the solution for A. So let's sketch the diagram. This is the ball, kick and form a trajectory pattern. So this is the O, this is the highest point, A, and it is 6 meters above the field. This will be 15 meters, this will be also 15 meters. Hence, the landing distance will be 2 times of 15 meters, which is 30 meters. B. So the roots of the equation will be x equal to 0 or x equals 30 because the landing distance will be 30. Then the equation becomes y equals kx times x minus 30. From point A, y equals 6 when x equals 15. So substitute the values inside the equation. 6 equals k times 15 times 50 minus 30. So solve it, we get k equals 6 over 15 times 15 minus 30, which is negative 2 over 75. Hence, the equation will be y equals negative 2 over 75 x times x minus 30. So this is the equation. Then C, we can start to sketch the graph. Start with the x-axis, and we know this is the y-axis. We know the roots, right? This is the curve. The root is 0 and 30. This is the line of symmetry, which is 15 is the x value, and 6 will be the y value. Right? So this is the graph of y equals negative 2 over 75x times x minus 30. Right now, it's your turn to try example 9 yourself. An archer shoots an arrow from point O on a horizontal ground. The arrow flies in a trajectory which can be represented by an equation. It reaches the highest point 8 meters above the field and hits the target, which is at a horizontal distance 90 meters away from O. A. At what horizontal distance is the arrow from O where it reaches its highest point? B. Let O to be the origin, x meters to be the horizontal distance of the arrow from O, and y meters to be the height of the arrow above the field. If the equation of the flight of the ball is represented by the equation y equals k bracket x minus a square plus b, where k, a, and b are constants, determine the equation. C. Sketch a graph of the equation that is obtained from B. You can pause the video and try to do it yourself. Alright, so here's the solution. For A, we should sketch how the arrow moves. So this is 0, or O, the starting point. This is the highest point, where it is 8 meters above the field. So the landing distance is 90 meters, which means that the middle point is 45. Hence, the horizontal distance will be 90 divided by 2, which is 45 meters. Now for B, the coordinates of the highest point will be 45, 8. Then y equals k bracket x minus 45 square plus 8. When x is 0, y is 0. We substitute these values into the equation. 0 equals k times 0 minus 45 square plus 8, which is k equals negative 8 over 45 square, and the value is negative 8 over 2025. Hence, the equation becomes y equals negative 8 over 2025 times x minus 45 square plus 8. And see, we can start to sketch a graph, the x-axis and the y-axis. This is the curve, and this is the first root 0, which is at the origin as well, and this is the second root 90. This dotted line will be the line of symmetry, and the x value is 45, the y value is 8. So this is the graph of y equals negative 8 over 2025 times x minus 45 square plus 8.